Thanks, Guy, for attending this webinar. I hope it's fulfill your expectations, and looking forward for an interactive session after all with all your interesting questions posted. So before entering to the subject, I just quickly introduce SN Integrity, established in 2017 with a vision to be a preferred provider of state-of-the-art ultrasonic technologies. We since then have secure links with smart UT industry leaders in this area. One of them is Ionix Advanced Technologies that we are introducing today. This is the agenda. As I mentioned, I will do the introduction. So I will be talking about Ionix itself, and then hand it over to Will and Nigel that will go from point 2 to 11, talking about the high temperature online UT inspection pros, metal loss monitoring as an integrated solution. Point 4 will be advantages and savings of the system. Point 5 will develop us forward about the industry challenge today. With point 6 reflecting on the benefits, easy to installation and easy to measurement verification. Then they're gonna talk more about auction for data collection and auction for data integration, and discuss a little bit about measuring viewing and system management software. And concluding the part with some case studies where you can use this system, and hopefully having your Q&A after that, so we can round it a good session. So Ionix is today the strength environment condition monitoring expert with the Hotsense line of products, which are designing with in mind to help you optimize quantities that best fits location where you go high temperature issues, and nodes to minimize equipment needed. The data and system management provide more accurate and consistent data, improving the safety of your facilities. This data can be fed into your RBI system, for instance, to do fitness for service calculation or corrosion rates, end of life forecast calculation, or inhibitor performance validations, coupon and corrosion pros, data cross checks. So all of this data can be stored on your asset management platform, allowing better decisions to be made, which ended up increasing productivity and reduction of costs as a result of informed decisions that are made. But overall, the system is flexible. So at the back end, they can also provide support services, both to confirm system is working as designed, general maintenance, and also should your requirement change in the future, either personal training or asset needs, redesign the system. So it started back in 2011 to commercialize piezo ceramics and ultrasonic technologies, UK based, and for development and manufacturing of piezo ceramics from raw materials to sensors and solutions designed for work at high temperature. The multidiscipline team under one roof, allowing in-house manufacturing, enables them to control design parameters and quality build from the ground up to produce best spoken solution for your most challenging situations. Since 2011, they have established a global network of partners worldwide with local services in mind, with major oil and gas companies already using Ionix system solutions. And we are currently working with New Farm, a local fertilizer producer, to install the first Ionix system into a special titanium vessel that they have to monitor. Ionix have accreditation to meet all standards for quality and safety for real-world industry requirements. It is ISO 9001 certified, but it also go above with the CAN, or the Quality Assurance Notification, which is an ATEX directive for the EU and UK for equipment used in zones 1 and 0 for a mandatory quality assurance system. Also the QAR, or Quality Assurance Registration. This too is mandatory quality assurance manufacturing system for companies that apply for an ISX certificate of conformity. Sometimes this is referred as ISO 9001 on steroids. So that gives you an idea of the quality system that Ionix got in place. All of this, as mentioned, is supported by a qualified global regional partner for installation across the energy industry. Okay, now I hand it over to you, Phil.
Thanks, Nestor. If you could make me the host, and then I'll share my screen.
Yeah, we'll do it in a sec.
Let's skip over these front slides, as you've presented those already. Nigel, I'll give you a remote control as well if you want to go through. Do you want to start, Nigel?
Yeah, I'll just go through very quickly. Hi, good morning. It's Nigel Baxter here. As Nestor said, I'm the Business Development Manager for the Eastern region. And just first of all, go through a brief overview of our product map. So we do basically two main standalone product ranges. One is the inspection probe, which we'll talk about in more detail first. And then we also do alongside that the monitoring sensors. And they are also paired to a range of different deployment mechanisms, and then also a range of, again, all the range of sensors fit any one of the data collection methods we have, from manual, hybrid, and wireless. So at the core of what we do, as Nestor mentioned, is the unique piezo ceramic. And this is used to work in extreme environments that may be temperature or vibration. So they're very solid, both the sensor and the coupling and the deployment systems in these extreme environments. This next slide. Yeah. So first of all, Will, I'll hand back to you so you can introduce the inspection probe.
Okay, so first product that I'll present today is our HS582i. This is a dual element UT inspection probe. It's 5 megahertz. It's designed for on-stream high temperature spot thickness measurements. It works with any standard UT thickness gauge or flaw detector. The difference really between this probe and ones that you might be using already is that it can be used continuously on surface temperatures up to 350 degrees C. And above 350 degrees C, up to about 550, you can use this probe, but with duty cycling. So the advantage of having this high temperature allows you to reduce the time at asset, because you up to 350 C, you don't need to duty cycle the probe, so your inspections are quicker. That also makes it safer. And the probe itself has actually got an increased wear resistance compared to a standard inspection probe. So this, combined with the high temperature, means it's much more resilient. You're not going to burn or wear through these probes as quickly. And it also makes it a great probe to use for scanning. One of the advantages as well is that because the probe can be actually allowed to heat up to temperature, you have some opportunities around calibration. You can just calibrate on a step block at room temperature and then take spot measurements, and then post compensate for temperature from those spot measurements. So for example, apply the 1% speed of sound per 55 degrees C change in speed of sound, and that's recommended. But you can also allow the probe to heat up on a hot test block, calibrate at temperature, and then take repeated measurements either with a grid or for scanning with a pre-calibrated probe that won't need repeated calibration. Just a video here showing the probe in operation. As I said, it works like any standard UT probe. Here it is. This is working with the Olympus 38DL Plus. It's a very common thickness gauge. It even works with the automatic recognition. So very simple. This is just at low temperature at the moment now, so 21 degrees C ambient temperature. Calibration on a step wedge, and then it works on a hot pipe. But here you can see sped up. It's actually being held on a pipe, which is being slowly heated up over 30 minutes to 330 degrees C. Probe is fine. No change in its operation. Just, I suppose, as proof here of that, it's very quick and very easy to take spot measurements using the probe. And at this point, the probe has heated up. The probe is hot because the user's wearing gloves, and the pipe is also hot. So left on for a long period of time here and able to collect very stable and repeated measurements. We also supply a range of couplants for use of these probes. They're supplied from our partner Echo Ultrasonics, and those couplants are suitable for a range of temperatures, all the way up to 675 degrees C, so exceeding the operation of the probe. The different couplants you would choose based on the temperature which you're operating in. We always recommend that you choose the lowest temperature for where you're working. It tends to be that the properties of the couplant perform better as you reach that optimum kind of operating temperature range. We also provide a range of accessories to make the probe easier, quicker, and safer to use. So handle extensions all the way up to 12 inches. What we call the couplant dispenser, which sits on the front of the probe and protects the probe for doing port inspection, and then allows you to press down with couplant on the front of the probe to take a measurement. We also now provide as well cables. So these are high quality, high temperature cables with abrasion resistant coatings as well. Nigel, would you like to take over?
Yes, thanks, Phil. So moving on from the manual inspection that we just spoke about onto the monitoring, and just a little bit about where we fit into the whole asset integrity risk-based inspection. So obviously, as you're probably very aware, risk-based inspection is about finding out where your defects are, where your corrosion is, monitoring that, and doing inspection, and then moving around an integrity wheel where you are basically repeating that process of understanding what is the defects, what is the corrosion rate. And that's one of the key differences with monitoring to inspection. Inspection can find those defects, and monitoring will never replace that inspection requirement. And in fact, our systems are designed to aid in that whole process. So again, you'll note on the, particularly the high temperature ones, the mechanical straps that we'll show you enable you to remove those sensors so you can repeatedly visit an area and repeat the inspection scan to ensure that there is no change in where the defects are occurring. But key is that the monitoring allows you to take regular repeated thickness measurements at a fixed point, so that you can understand what is the corrosion rate. This can obviously be down to once a day, once a week, once a month, and even once an hour if needed for erosion failure mechanisms. One of the key differences with our system as well, from a point of view of high temperature, as you're probably again aware, when you're doing manual inspection, typically the standards allow you to go from 0.1 millimeter accuracy of ultrasonics to 0.5 millimeters when you go to 380 degrees C. With our Hotsense sensors, you maintain that absolute accuracy of ultrasonics at 0.1 millimeter. Again, we'll talk a little bit further about the change resolution when we get onto the automated systems. Part of the reasoning for looking at monitoring solutions is, again, how that can save you money. And this obviously is on a number of fronts. From a point of view of the fact that you can install the systems that we've developed online, so you don't need a shutdown. You can extend the life of your equipment by understanding that corrosion rate, and that may mean that you can better plan replacements, but it can also mean that you can extend the life by understanding the corrosion rate and knowing that you can actually run an asset at for a longer period. It can help in understanding the corrosion inhibitor. So again, you can optimize that corrosion inhibitor. You can understand that you can actually reduce your inhibitor use by understanding what the corrosion rate is. And also you can reduce the shutdown inspection, because if you are, again, monitoring, and again, coming back to the risk-based inspection model, typically where you have holes in being able to carry out a risk-based inspection is where you have assets that are difficult to get to, the high temperature, they're at height. If you can install a monitoring solution, you can remove those difficult to reach areas from your shutdown and therefore potentially reduce the shutdown window. And it also gives you the ability to optimize the feedstock. So in a refinery situation, you can understand what is the impact of using a certain feedstock and therefore say, yes, we can use this feedstock, but this is going to be the effect, or this is the effect on my asset, the corrosion rate. Or you can understand that you can increase production by a percentage by understanding the corrosion rate without adversely affecting your asset. Oops, sorry, I seem to have jumped on a bit there. So just very quickly, the reasons that we designed our solution as we have is we went to the marketplace, we asked some questions, and some of the key deliverables from that, or the challenges that clients told us about, were three main things, really. There's a few that you can see on the screen there, but three main ones. One was we don't want to, on high temperature assets, we don't want to breach our CUI defenses, the insulation and weatherproofing, particularly in high temperature, high humidity areas. And again, most refineries are on the coast where you have salt-laden environments. So we want the sensors to fit underneath our insulation. The other one is we don't want to weld. Welding means that it's another point that you have to do some form of assessment on over time. It also means that you typically have to have a shutdown to do that welding onto an asset. And the third one is we want the data to remain within our fence, and we want that data to go into the software solutions that we're already using. Again, RBI software solutions, asset integrity management software suites, are expensive investments. And if you then it's difficult to get data that you're collecting into that system, that again is another running cost that you want to reduce. And that was, again, one of the feedbacks that we got. So that's why we ended up with the system that we have. Will, I'll hand back to you so you can run through the sensor itself in a bit more detail.
Yeah, thanks. So the sensor is designed for continuous use with our low profile probe up to 380 degrees C, and with our ultra high temperature probe all the way up to 550 degrees C. The idea of this is it allows you to extend the locations where you can inspect and monitor. It's got a rugged design. It's a full metal housing in the transducer, and it's less than 50 millimeters in height. So this means you can install it under insulation and under weatherproofing. The probe itself for the 380 probe has a 25 millimeter stainless steel delay line on the front. The delay line is there to allow you to take shallow measurements, but it also gives you I suppose a known reference reflector, and we can see that in some of the later slides, which is really important when you've got installed sensors, because you need to be able to potentially validate the measurements remotely. You can't take the probe off and put it on a test block and see what's happening when your measurements change. Although we offer a range of installation methods, our most popular method is these clamps. So these are popular because they can be installed without welding. They're very quick to install. They can actually be removed as well, and they can be installed while the plant is operational. All the metals are stainless steel, and they're also passivated as well, so you wouldn't have any problems with galvanic corrosion between the transducers and your pipes. And as I said, that the whole system is designed for use during operation, installation during operation, and the transducers themselves are certified to ATEX and IECX Zone 0, and then we have them certified with systems as well, which also cover the FM certifications. One of the big questions we always get with these install probes is, how do they couple? How do you get ultrasound in, and how do you do it consistently at high temperature and over a long period of time? So we have a really simple solution. We use a metal foil on the front of the probe. It's all held in place and assembled off-site. So the middle image that you can see here is a probe assembled with the loading plates and the foil in the front. And we basically just compress the foil between the probe. It squeezes out all the air. It gives you excellent acoustic impedance match, metal probe, metal foil, metal pipe. And this kind of coupling is suitable for low temperatures all the way up to high temperatures. And it will survive thermal cycling, long and permanent holds at high temperature. The installation of the probe is extremely simple. I'll show a video here of it being installed on a pipe. I think this is at about 230 degrees C. So you have to remove surface coatings and any roughness. It's down to a near white metal finish. It can be done just using a simple hand file. You don't want to flatten the pipe. You know, we're trying to minimize the removal of material here, but it's really just getting rid of coatings and rust. Tighten it using a wrench on the strap, and it's the same tool, the same hex key for the straps as the transducers. The transducer with the foils dropped in, initially hand tightened, and then we actually connect this just to a standard thickness gauge floor detector, because it works like a standard UT transducer, and then we're just tightening it up on each of the bolts to a set torque, and then the coupling that you get from this is stable, and it's stable for many years, and even if the pipe is heating and cooling as well. It's one probe per strap, but multiple probes can be installed and pushed up next to each other if you want to monitor cardinal points. We do one probe per strap, because this gives really the highest level of security and robustness of the installation. These are often installed in difficult to access locations, and you don't want the sensor coming loose during operation. So going for a single probe per strap is the solution for that. And they're low profile, so you can install installation over the top with the cables exiting just at joins. In that example there, the customer was using a temporary installation over the top because they wanted to re-access that area later. It's another reason they went for the strap probe, so that they could easily remove them. I mentioned about the validation of the measurements. So the front section of the probe is a delay line, and what it means is that with every measurement you get, you have a reference point from which you can take your thickness readings. It's really useful as well just to see once it's installed. I'm not sure of your UT experience, but by looking at the ratios and the amplitudes of these peaks and how relevant and their relevant ratios to each other, we can gain information about not only what's going on with the transducer, but also extra information about what's going on in the pipe other than just the change in thickness, for example. Probes for use with the monitoring system also have built-in thermocouples. This is really important because as the pipe, the asset, or the vessel, for example, changes temperature, then you need to be able to compensate for the change in the speed of sound to get consistent thickness readings, and our installed sensors have that included with them. I suppose just a very quick example of an installation. This is on a refinery, but also just to point out the kind of record keeping that's kept as well. So with all of these projects, if you installed fixed sensors, it might sound really strange to say now, but quite often, you know, you can install these things and then people can forget where they are, can forget how the installation was done. Our procedures are all done so that the record keeping, the identification of where they're installed, what pipe they're installed on, what information they're gathering, is all simple, but well recorded as well. So we make sure anyone installing these probes is trained in those procedures. So Nigel, maybe I'll just try very quickly do this one and then
sure.
continue on. So just comparing the installed sensors to, I suppose, one of the other sensors that's available on the market, which is maybe one that's been seen, has been around for a bit longer, was the PermaSense system, which is it's a really good thickness monitoring system from Emerson. It was actually the first to market, and it's given us a chance to look at what some of the failings of that system were and address them. So our probe is a true, I suppose, low profile under installation system. It doesn't breach or break through the weatherproofing or the insulation. Now it means that you can reinstall this over the probe and give you the kind of integrity that you need for your CUI defenses, prevent water getting in. And it also means that the probes aren't exposed to damage, people bending them, wind blowing on them, causing vibration and fatigue, for example. Also for high temperature, we offer this very simple to install strap. So there's no stud welding, which is required for smaller pipes. We do offer stud welding as an option, but only because some people have asked for it. But the majority of people have gone for the strap mounting system as well. And I suppose one of the key things as well is that the reason we can go low profile is that this is a true high temperature probe. We don't need to protect or isolate it from high temperature. Our electronics are connected when we taking measurements to a wire connected to the probe. This is really useful because it means that the batteries, the electronics can be installed away from high temperatures, but also in an accessible location as well. Because electronic monitoring equipment, it needs to be powered. The easiest way to power it is with batteries, but batteries do need to be replaced. So you need to make sure they're accessible for that to happen. So the probes, as I said, we have this 380 low profile probe. We also have a probe which will go up to surface temperatures of 550 degrees C. That's a little bit taller. That's about 5 inches taller. And we also have a new low profile dual element probe, which is coming out. So this will work at temperatures 150 degrees C. The advantages of this probe is it can work through coatings. So it's great for upstream applications and coated pipes, standard epoxy coated pipes, painted pipes, for example. And this probe will also, for these lower temperatures, work with a magnetic and epoxy-based coupling system as well. So no need for straps for this probe. So it's great if you have a really large pipe or vessels, or you want to install multiple probes in a single circumference. This is the one for the job. In terms of data collection, once these probes are installed, as I said, they work like normal UT probes. So you can use your standard thickness gauges, your floor detectors to take measurements from them. And the probes themselves can be left in hazardous environments, but just worth noting that unless your data collection device is certified, then you would need a hot work permit to collect data from them. The advantage of installing one of these probes, though, compared to the inspection probe, is that with a fixed probe like this, you get much better trending of data using the same probe in the same location, and the same piece of equipment and procedure to collect measurements from it each time. So it's much easier to get trending data for wall loss. It also means that you can install the probe in an inaccessible location, in a hazardous high temperature location, and run the cable, so up to 15 meters, to an easy to access location for data collection. We also offer a solution for use with these probes called the measurement hub. It really is quite simple. It's a cabinet where you can terminate the connectors for the cables. So that's the LEMO connector for the probe, but also the thermocouple connectors too. What we've basically done here is we've done the hard work of putting together a cabinet, which is also compatible with the ATEX and IECX explosive certification standards. So we have an ATEX dossier which we supply with this, and it means that you can install up to 4 probes, have them all terminated in this cabinet. And if you want to collect thickness measurements from it, you simply plug in your thickness gauge or floor detector and trigger a measurement and move on to the next probe. And it just makes data collection from these easier, and it makes the actual site installation and integration easier as well. It's a neat solution, a simple solution. But what's really important here is it allows you to start getting more accurate trending data from fixed sensors without the big CapEx spend that you'd need to spend on a full automated system. The full automated systems are incredible, and we'll have a look at them in a minute. They're powerful, they generate a lot of data, but they can be a big commitment, particularly for smaller sites, because you need the wireless backhaul for them. This is a solution that allows you to start on that journey, install sensors, see how they work, see what kind of data you're getting from trending sensors, but collecting data using your local site teams, your contractors and their equipment. And then the same sensors which are terminated in the measurement hub can also be connected up to our automated systems too. We also offer another kind of hybrid approach here. So instead of using the measurement hub, you can install these patches on the end of the probes. The patches enable data collection from a system called the Wand, which comes from a company called Ultrasonic. So the Wand basically uses RFID, it uses inductive technology to pulse and power the probe through the patch, and then it can take pre-configured measurements because it can identify the location from RFID chips installed. And what this does is, once set up, it allows very quick data collection from these installed sensors by anyone. Really, you don't need to be a UT inspector. Once this is pre-set up, any user can hold the wand over the patch, press the button, and it will take a thickness measurement. You still need to be on site, obviously, to collect it, but it just makes the process much easier and quicker. So we work with partners Mistras to produce a fully automated wireless heart-enabled monitoring system. It's called the Caliper Array. So the Caliper Array can connect up to 4 sensors at once. It uses a wireless communication system called Wireless Heart, and the full system is battery powered and certified to ATEX Zone 0 and FM Class 1 Div 1. So you can put it in your most hazardous locations. It has a change resolution of about 1/1000th of an inch, but it is close to about 0.02 millimeters. The change resolution is really important for picking up corrosion rates and trending data. So very quickly then, a summary on our portfolio then is that we offer this kind of journey from fixed sensors with manual data collection using your standard hardware, terminated with the measurement hub, this hybrid system, which is a kind of a combination of automated and wireless, but with the user still being on site to collect that data, all the way through to our fully automated wireless systems. Jose, do you want to add anything about the kind of drivers and so on?
Yeah, well, just again, as a part of that summary, again, we can, if you tell us what it is you're looking for and looking at the different solutions that we offer, and generally it's around, how frequent do you need to take a measurement? Is it once a week, once an hour, once every 2 months? How many locations do you have? Is it just 3 or 4, or is it 100? And how easy is it to get to those locations? Are they on ground level? Are they at height but near a gantry? Or are they on an overhead pipe above a vessel that you can't easily get to without scaffolding or rope access? And if we can understand what those drivers are, we can then help you design the system to suit your requirements. And as Will mentioned, we have various solutions, which means that we can tailor it to suit what you need. From a point of view of the volume and size and what's the most cost effective, but also how you can then build on that. So if you then decide, yeah, we actually do need to move to a automated solution, we've started manual, you can use the same basic sensors and then start plugging them into an automated system in the future as you grow the system as you need to. Okay, thanks all.
So just give a bit more information now about the wireless system. So we mentioned it uses a protocol called wireless HART. So this is a widely used industrial standard. It is a self-healing, self-managing mesh network. So these probes, the nodes, on this network are designed to relay messages between them. So this means that you can have a network to cover a process unit, which has built-in redundancy. And if one path from a system gets blocked, it can reroute and will automatically reroute data back via another route. All this wireless HART data is collected at a wireless HART gateway, and gateways convert one protocol to another. So it takes this wireless HART signal and it turns it into a wired message that can be with data that can be collected directly to a server. Could be running our software, we'll come on to that in a minute, or a workstation, or directly into your actual monitoring systems too. We offer a range of ways of collecting and accessing the data. There's a lot of information on this slide, but I won't go through it all now. But the key thing with CalipArray is that CalipArray is doing all the number crunching actually in the node, in the electronics in the field. So it's actually sending a pre-calculated thickness measurement. It does send the extra information such as the temperatures and so on as well. But these are sent as what's called primary variables, and they're available in the wireless HART gateway to be read directly into systems such as a DCS, your historian, or other. And this is really key because this isn't acting as maybe a flaw detector in the field. This is acting as a true field device like a temperature sensor or a pressure sensor, and just transmitting these already calculated values back. So it makes the process of using this very simple for the user. We do also offer some software called the Web Access Management Portal, and we can run this on a server, and it has a number of components, including a database and a web application. We would recommend that even if you are taking data directly from the gateway, that you also run our software too, because it offers some really powerful and extra features. So around you can collect waveforms, they're A scans, which is really useful for validation of measurements and also maintenance. But you can also control and manage the network using the software, and it also contains built-in corrosion rate and trending functions as well. You may already have these in your historian, but we have ones built into the software which are extremely easy to use. And you can also export the data from the web application if you choose. So just very quick summary then, this is what a wireless HART network would look like. You'd have up to 4 sensors connected to a single CalipArray unit. This CalipArray unit would be communicating with other nodes on the network. And because it's fully wireless HART compliant, they don't just have to be CalipArray nodes, they could be any other wireless HART device, such as these acoustic sensors from Rosemount. And that signal is then collected by the gateway and then transmitted to a private network. This is designed to all be run on a private network within a plant, and so there's no need for the data to leave the site. But we can also set up cloud-based systems if the user wants. So for remote locations, for example, we would install a cellular gateway, or sorry, a cellular router or a satellite terminal, which can allow data to be transmitted via the cloud, via the internet, to either a locally stored server or even a cloud server as well. So ultimate flexibility. The WAMP software itself is it's quite simple to use, but it's got a lot of power hidden underneath it that you may not realize. And it's got a really nice way of just displaying all of the data and all of the nodes. So it does it by location. So if you're running a large plant with a number of different process units, or maybe this is a cloud-based system where you have a number of different remote wellheads, for example, you can organize them all by location and gives you a very quick overview of all of the CalipArray which are operating within each of those. But then you can also view each of the, clicking on, look at all the nodes that are within that location as well. with all the key information that you need, so such as the last thickness measurements, the temperature, and then information about remaining battery life in days and so on. But what people usually want to see is they want to see the trend. So this is all of the previous thickness measurements as a function of time. So the trending is really useful because it allows you to determine things such as corrosion rate, and it allows you to see changes. So we can overlay corrosion rates onto these. So a total corrosion rate or wall loss rate, because I suppose really you don't know if it's corrosion or erosion. And then but also change the period of when you're looking at, so look at short term, long term, for example. And this example here, you can see that the thickness measurements, where you can see there's some scatter, but we're zoomed in here. So the actual distance between these steps is 25 microns, so it's tiny. And up until, in this example, September, they had very low corrosion rate, so less than 25 microns per year. But then there was an event that happened, maybe a change in processing, that's caused a very sudden loss in wall loss. So it's jumped up to 1 millimeter per year, which would need some kind of intervention. You can also see in this example that the temperature of this pipe, the asset dropped from operating 260 to 80 degrees C down to close to room temperature ambient. And there was only a very, very small change in the measurement that was observed here. So there's the excellent temperature compensation. So we do offer, and Nesta already hit on this as well, complete solutions here. So using our local partners and also with the support of Ionix, we can provide surveys where you can indicate where you'd like the sensors installing, and we can confirm the sensor that we would install in those locations. So taking that all the way through to kind of system design, but then supporting through the project delivery as well with the installation, commissioning, and really important, I can't really stress this enough, is that we offer this kind of ongoing support as well once the systems are installed. We don't want to, for you to buy a system for it to be installed and then for it, just over time, maybe the people who set that up to move on and the system to become used less. We want to make sure that this system generates the data that you need and adds value for the foreseeable future. So we offer ongoing support packages, usually a kind of review every 3 months to make sure that the data you're collecting is still valuable, make sure the system is operating correctly. And if needed, we can plan and schedule maintenance using either your teams, if you want them training, or with our local site partners. Another quick example, this one is in Antwerp. Here they already had a wireless heart mesh network. It was running a range of vibration and temperature sensors, and they basically just dropped some caliper in on site, automatically integrated with the mesh, and then started sending data directly back to their control centers. Another key one for this is that they wanted to install some sensors above heat exchangers. Now, the problem with this is that the temperature above the heat exchangers, the actual ambient temperature, was about 250 degrees C. So you couldn't install the electronics there. So the electronics were installed nearby with lower ambient temperatures, and another key benefit of the system. And I think I'll just skip forward to this example here. This was an example of a wellhead, a remote wellhead in the Permian Basin in the US. This was an unmanned wellhead that was operating outside of its standard process conditions. And they were currently having to do X-ray, so RT profiling once every 2 weeks. With working with Shell, we were able to validate our probes for use for monitoring. In this application, it was erosion on these elbows, and using a cellular gateway, stream data back to a server so that the team could collect and manage the thickness measurements and the wall loss without the need for any X-ray. So ultimately saving costs, but increasing safety as well of this site. So I suppose in summary then, our solution is low profile, can be installed under insulation and weatherproofing. It's flexible for where it can be installed. And it really importantly is that by separating the cable, the transducer and the electronics, we allow for more flexibility in installation with accessibility to the electronics for maintenance and other activities. So Thank you very much. That's the end of the presentation. Let's try to finish maybe just on time, but if you've got any questions, or if you want to go back to any of the slides, then you know, you hand that opportunity over to you now.